Hi, this video is about different forms of energy in physics. Mechanical energy is energy that comes from an object's position or motion. If you're moving or you have the ability to move, you probably have mechanical energy. It's a pretty broad category because if you have potential energy or kinetic energy, put them together, that's mechanical energy. Some examples that I thought of for this, there are so many different kinds, but just some random examples here. If you open up a microwave door, it probably has a spring in it that pops the door open when you push the button. That's mechanical energy. It's stored in the spring before, and you push the button and it pops open. That's mechanical energy. Another common example is wind. If it's moving, it's got mechanical energy. A car is another great example because it's got a lot of this mechanical energy if it's moving, or even if it has the potential to move. And finally, a roller coaster. At the top of a hill, it's got a lot of potential energy, but that turns into kinetic. That's all mechanical energy there. I was always very proud of my roller coaster drawings. I was my favorite thing to do in middle school when I was bored in class was to draw roller coasters. Another form of energy in physics is chemical potential energy. This is energy that's stored in the bonds between atoms and molecules. An object's chemical potential energy can be released when its molecules are kind of given a push over some threshold, and that allows them to undergo some kind of chemical reaction. So an example of this would be batteries. Batteries have chemical reactions taking place inside of them when you hook them up to a circuit, and that allows them to carry electrons through the battery and generate some electricity, kind of unleashing that chemical potential energy that's stored in the battery. Wood, as an example, or anything that burns has chemical potential energy in it because when you set it on fire, you let chemical reactions take place and unleash that energy in the form of heat. Another great example of chemical potential energy is photosynthesis. When sunlight hits a leaf, the molecules and chemicals inside of that leaf get rearranged in such a way that it stores energy in the leaf, and it carries that energy to different parts of the plant, gives it the energy to live and do all of the plant things it needs to do. Another example would be digesting our food. So when you eat something, you're consuming this energy, and the energy from the food is taken and broken apart in your stomach and in your intestines, and it takes all that energy that's stored and it reuses it in your body and stores it in your body in different ways. So that's chemical potential energy. A very common kind of energy is called thermal energy in physics. This comes from the random motion of atoms and molecules within objects, and it's related to how hot the object is, what the temperature is. And over time, the energy in any closed system will dissipate or scatter or break down into thermal energy. And that's the second law of thermodynamics there. Thermal energy is very common because, even if you just rub your hands together, you're creating thermal energy there. Energy that's used to keep your heart pumping, or any energy that your body uses, eventually turns into thermal energy. And that's why we have body heat that gets released into the air, because you have energy in your body that turns into thermal energy. When a car brakes and slows down, the energy of that car doesn't disappear. It turns into thermal energy in the wheels and the brake pads, sometimes on the road surface itself, or even the engine releases heat into the air. So all of those are thermal energy coming from a car. And then another, just kind of a random example, anytime you have a collision that takes place or something that hits the ground, that energy sometimes gets turned into thermal energy. So a bowling ball running into some pins here and crashing into the backstop, that turns all that mechanical energy from the bowling ball into thermal energy. Electrical energy is energy from the position or motion of electric charges. Oftentimes this is going to be electrons. Electric charges can move in a variety of ways. They can move continuously through a circuit like this, where a light bulb is being powered by a battery. They could be vibrating back and forth inside of home circuits, like you plug into a wall outlet, you have alternating current. Electrons are being pushed back and forth in this loop. You can also have electrons being transmitted in coded patterns inside of circuit boards. So any kind of electronic device that has a circuit board is going to have electrical energy that's being transmitted in pulses or bits, coded in patterns for electricity. So this is all different kinds of moving electric charges. Electrical energy can also be static. It could be at rest. So if you have electric charges building up on an object, that can also possess electrical energy. Acoustical energy, or sound energy, is actually a type of mechanical energy that we can hear. It comes from a disturbance that most often is a disturbance among air molecules made by a vibrating object, which propagates or spreads out as a sound wave. Sound can also move through solids and liquids, but most often we're talking about sound waves that travel through the air molecules bumping into each other, passing along a wave disturbance. Maybe the most unique form of energy is electromagnetic energy, also known as radiant energy. This is energy that's generated by electric charges that accelerate, and it's carried by electromagnetic waves. These waves can carry through empty space, and this includes visible light. So we're talking about light waves. They travel at light speed, and this kind of energy carried by a light wave can be absorbed and used by matter. So objects can absorb this kind of energy and then use it for different purposes. Photosynthesis is the most, obvious example, where plants will absorb sunlight, electromagnetic energy, and then use that energy from the sunlight to rearrange some molecules and make chemical potential energy out of it. We can also absorb electromagnetic energy in our own skin and use it for vitamin D. We can also absorb it through solar panels and use electromagnetic energy that way and turn it into electricity. And finally, you can just absorb light and raise the temperature of an object. It turns into heat that way. Just absorbing electromagnetic energy can be turned into heat. And then electromagnetic energy can also be emitted by matter as well. If you heat something up, it can start to glow in visible light waves. Finally, we have nuclear energy, which is energy that's stored within the nucleus of an atom, which is in the very core of an atom. There's two different kinds of nuclear energy. There's fusion and fission. They sound similar. Fusion is when you take two atoms or two nuclei and you fuse them together, make them into one. When this happens, when you do this with light elements, they give up a little bit of their matter. Each individual piece kind of loses a little bit of its matter, and that little bit of missing matter turns into energy in the form of light or electromagnetic energy. For fission, if you take a large nucleus and split it apart, you throw something at it and split it apart, these two parts are actually more stable. And so just like before, they become more stable and they release electromagnetic energy in the process. And so both of these processes release electromagnetic energy, light energy, which can be absorbed and used in other ways. So this fusion process is what happens inside the core of the sun. The sun is currently fusing hydrogen into helium, which releases light, releases electromagnetic energy. So it's a very important process to understand. This video has been brought to you by the chemical potential energy that's in my body, which I got from eating the food that I ate, which got its energy from photosynthesis, from capturing sunlight. So this video is brought to you by the sun. And remember, this day could be your last, so live on purpose.